welcome to another Tori Harris monthly meetup. I, Richa, will be moderating this meetup titled Transforming with Microservices, Adopting the Right Approach and Tools. Today's event will focus on expected challenges, tools, and approaches that will help enterprises integrate better. I would like to begin the meeting by introducing our speaker, Ms. Pramitha Baliga. Before I give the handover, I would like to share a little bit about her. Pramitha is a hands-on technologist with over 11 years experience in the integration space. She specializes in digital transformation and application modernization, where she takes the lead position to help realize outcomes. She is currently working with the telco customer consulting on microservices and integration. Without further ado, I will hand over the controls to Pramitha. Over to you now.
Thank you, Richa. Thank you for the quick introduction. First of all, very warm welcome to everyone for joining today's meetup from Tori Harris. As Richa mentioned, today's topic of discussion is transforming with microservices, adopting the right approaches and tools. As we all know, microservice is a buzzing word in today's era. Every enterprise, which is whether it is a small scale or large scale, who want to transform to a microservice architecture is basically looking for some benefits from that. Definitely, microservice has ability to give do a greater good, but if at all we are not adapting the right tool and approaches, we will end up with a lot of challenges when we are migrating to the microservice architecture. So today, let's see, why do we need microservices? What challenges we face when we are moving to a microservice architecture? How do we identify a best fit for microservice architecture, or when can we plan to move to a microservice architecture? A case study with the success story where a customer was able to move successfully to a microservice architecture, and the approaches and tools which we can use or adopt basically when we are transforming into microservice architecture, we can see this. To start with, why do we need a microservice, or what are the benefits that we get from a microservice architecture? Microservice is a wonderful concept where each service is basically self-contained, independently deployable application. So anybody who is developing it have to just worry about the complexities which are part of that particular microservice. So anything outside that, any other microservice will be a capability which is serving a certain functionality to them. Something which is common across platform or across domain, it can be split out to a different microservice altogether so that it can be reused in different functionalities. Similarly, when we say about the deriving the output or rendering output to a particular client, we can customize that, and we do have a flexibility to customize it and send it in a way where the client expects, what the client expects. Now, this overall, if you see, usage of microservice, basically it reduces complexity of solution. So that's a first benefit what we get if you're moving to a microservice architecture. Next things come is scalability. If you consider a monolith application, what happens is when we are scaling that particular application, entire application as such will be scaled. Some part of code which is like not used as such can also be scaled in that. Whereas if you are considering a microservice architecture, as each service is independent, it can be scaled independently. And maybe during the peak hours, when the traffic is high on specific journey, only that part or that particular service can be scaled. So it becomes more efficient if you're going for a microservice architecture in terms of scalability, basically. Next comes the increased resilience. So in case of a monolith, again, if we go back to a monolith architecture, we can see that a part of code, if it is failing, that has an ability to bring down entire application. Whereas in microservice, as each service is independent, something which is failing in one particular microservice need not bring down entire use case. We will still be able to render a particular output to the customers. So also in terms of the minimum time required to recover. Okay, not only the fault resolution, the isolation, basically in terms of minimum time to recover is something we can achieve in a better way when we are going for a microservice architecture. One another important thing in today's era is that, like, as we are growing very fast in our digital market, so what we can see is any feature which we are releasing it to the outer world is it becomes very crucial. So faster time to market is the main thing which is required. So as these services are independent and they can be deployed independently, so there can be more frequent releases. At the same time, developing an entire use case or a feature as such will become much simpler because the complexity is localized there. At the same time, we can use some functionality from other use case as well, as they will be independent microservices. So growth wise, if we see, we can see a rapid growth if you're going for a microservice architecture. Next is like generally with the microservice architecture, what happens is there is a certain need of automation and DevOps concept setup or the process following the around that. So because of that, what happens is not only that, actually microservice encourages us to use different languages or technologies basically for the development of that. So because of this, what happens is technology wise, if we see, so we can say future proofing is achieved with this particular architecture. So these are some of the benefits which we get when we are moving to a microservice architecture. But the same thing, if we see from a different perspective, we can see challenges in each one of them. Now, what are those challenges? So we said that it is independently deployable and modular and bound to certain context. Now, when we say bound to a certain context, how do we define that? Or how do we define what should be a size of a microservice? That would vary actually from for with each perspective. Somebody can design a use case with the 10 microservice and somebody else can design it with 15 microservices. It's possible. So when we are designing, which is a very crucial stage in microservice architecture, when we are designing, identifying or defining a bounded context there, or designing a solution becomes our first challenge. Forming that granular level is our first challenge. So if something is not addressed in the right way, then we will end up with lightweight monoliths, basically a lot of lightweight monoliths. So that's our first challenge. Then if we move to a distributed system, as we know that in a microservice architecture, if you're going for any use case development, entire use case can be developed using 10, 15 microservices. Now that definitely gives us a distributed environment where there is a need of communication between them and there is a need for maintaining the data consistency. Now, the data consistency comes into picture because we go with the concept that each microservice can be aligned to a, basically is required to align to a particular database or a data structure, basically. So with that concept, when we go, ensuring that interlinked data is synced and is maintained, the data consistency is maintained, becomes another challenge. In case of any failure, so in the sequence of microservices, ensuring that we identify the right service, the right time, and ensuring that we build a logic so that even in case of that microservice failure, we still will be able to manage the application or end it gracefully is basically the next level of challenge what we'll get in a distributed system, basically. Next is testing. So as there are multiple microservices in an end-to-end testing environment, whether it is a manual testing or setting up a automation testing, ensuring that each microservice is available with its database and the right data is set for an end-to-end journey to be executed. So that becomes another challenge. Next thing is operational complexity. So it is expected that if you are moving to a microservice architecture, we should be having a strong matured operations team. Reason for that is if we say, for example, if you consider a monolith application, the level of monitoring what we have, or the log consolidation what we have, or the deployment patterns, or the process what we have, the same thing or the same knowledge cannot be carried to a microservice architecture, because this has certain other expectation where like number of services are more, every service can be deployed independently, so deployments will be more. So there is a certain expectation for setting a monitoring and log consolidation so that we will be able to handle issues in a much better way. So the complexity again in operations also increases. Next is about security and maintenance. So with the n number of services or microservices, basically, ensuring that each follow the same security guidelines and same thing is followed governance wise, also same thing is followed across all microservice becomes another challenge. Also, like technology wise, if we are going for a different technology or a different way of coding, so then the cross skill maintaining that and during in case of maintenance, ensuring that each skilled person is available to do that particular change is another thing actually we would face. Now, these are not the challenges which will block us from moving to a microservice architecture, but definitely they would be able to contribute or increase the complexity if not addressed in the right way. So when we say while moving to a microservice architecture, so how do we conclude or how do we decide that which particular application can be moved to a microservice architecture? So there are many scenarios or many use cases where we can identify an application which might be a best fit for moving to a microservice architecture. But in a general note or for our first level of filtration, if we consider broadly, if we have to identify some scenarios where we can move to a microservice architecture, I think those will be this. The first thing will be large scale systems, which has a complex logic. So such systems, if at all we are planning to move to a microservice architecture, the end solution will be much simpler, easily manageable. Those services will be we will be quickly able to deliver the changes on top of that, or the new feature can be released quickly. So in such large system, generally depth knowledge about the domains will be more, and we will be able to form the microservices or identify the microservices in a right way. So that becomes our first candidate. Next is rapidly growing application. So in domains like telecom domain, where every other day a new particular client or new particular device will be used to retrieve a data, or any new thing will be launched. So in such cases, scalability is our first challenge, ensuring that we will be able to handle the peak hour traffic whenever there is a new product launch or whenever there is a new promotion or a new plan launched. So that becomes a challenge. At the same time, releasing new features early to the market is another challenge. So these things can be addressed in such rapidly growing application with the help of microservice. Third one is a legacy system transformation. If any application is considered as a legacy and there is a plan for transformation, ensuring that it is future proof with the technology stack is something we can definitely achieve with the microservice. At the same time, as that will be in a very initial process of setting up or setting up the complete process, it will definitely help if you're going for a microservice architecture. Now, these categories are not everything actually, or we cannot say that anything which is falling in this category can always be migrated to microservice. No, definitely not. So with this first level of filtration, we have to further analyze that, and we have to see what is the process which is followed currently in those systems, and what are the challenges they have, so that like we'll be able to rightly come up with a solution in a microservice world or maybe something else. So these are the categories. Now, we had a telecom client basically who was falling in these categories. I mean, they had a problem statement which was matching these categories actually, and they were successfully able to transform into a microservice architecture. This particular client was basically a telecom giant from was a service provider basically in India, and they had an order management platform which was basically a product-based solution and had a challenge in scalability, also in terms of order processing time. So during peak hour, it used to take 1 to 2 hours actually for processing a single order because of various reasons, whether it's a failure or the peak of traffic or anything else. So they had this challenge. Similarly, increased time to market. So releasing a new feature was a challenge. Tracing those orders, if at all they are failed in a certain stage, so that facility was not there, and a large amount of orders were failing because of various reasons, which the retry or was not happening. It was always a manual situation there, and because of that, there was an order loss and in turn a revenue loss. with this problem statement, when they had approached Tori Harris, Tori Harris had done a product evaluation, basically process in the product evaluation, what was there currently set up. And we were able to successfully implement a microservice based solution, where our first thing what we had analyzed was the TM forum standard data model was used, and domain driven design practice was used. This is something we'll see in the next coming slides actually. And then we were able to transform the complete application to granular microservices, which are configurable and can be separated as a order or and the service based journeys. And they were built as Spring Boot applications, basically containerized using Docker, and were deployed. Now, as a result, what we can see is the orders which were failing, the manual, which we needed a manual intervention to make it a success, was like it was reduced drastically. Out of 100% technical error, what were resulting, those were transformed into a success by uh, re-triggering or basically a auto heal process, or re-pushing that particular order. Similarly, even the business case failures, so those were actually transformed into a success story. So then, as I mentioned, as their problem statement was basically order completion was taking a lot of time. That was something which was able to achieve a better success in that. And that particular thing was reduced to 15 seconds. Basically, the order completion time was reduced to 15 seconds. So this was a success story for a client who had come with a certain pain points in their current existing order management journey. I'm sorry, I think somebody is muted. If you can mute. Okay. So as a part of this, the as I mentioned, the order followers had reduced from 90,000 to 2% of total orders actually, and it was a success story for them. Um, this is not just by using tools randomly. So there was a deep dive session and a complete analysis was done to see what are the pain points and what are the approaches can be used, or the what are the right set of tools that can be used to achieve this particular success. Now let's see what are those approaches. I mean, it's not specific to this particular client, but it's definitely like in a generic note, what are the approaches we can follow when we are moving to a microservice architecture, or when we are planning to transform to a microservice architecture. So first thing is about the interface segregation. Basically, how we want to expose our service contract to the specific front end or client. So that the way we segregate it, something is what you can see here. In a microservice architecture, we know that there will be n number of services to come up with a particular use case to deliver that to a particular client. So client can be a web-based or a mobile-based. Um, they can directly connect to these microservices, not that they cannot connect, but generally what is preferred is having a gateway so that we do a right amount of security check, or like we do a authorization there, and then we do a throttling. And if at all there is a need for transforming that particular message to a different format, or protocol transformation is required, that can be achieved using this particular gateways. Now, once we do have this particular layer of gateway, can we expose every microservice to every client? Yes, in some case, but no in some other cases. Like, for example, if you take a web-based application, that might be okay to, I mean, it might be okay to connect to a 10 different backends or 10 different microservices to retrieve or to render a particular screen. Whereas in case of a app-based solution where like app is a client, so connecting to multiple services might actually impact the battery life and further the performance of that particular application or a device. Now, in such cases, not only that, if we see the data perspective also, now a web-based application might be okay to display a lot of data, whatever is retrievable, whatever is possible to show. So we would be having a bigger screen to display there. Whereas in case of a mobile-based application, a crisp data is required. So where a specific information is required. In case of use case also, if you see, if we want to search something in a web-based application, we might be ready to, or we might be okay to type anything and search that particular product. Whereas in a app-based application or a journey, we might be interested to search something based on the image what we upload, uploading an image of a product what we want to search, or scanning something. So use case itself will be different. So in this scenarios, as the user experience itself is different, defining a single API to every kind of client is something is not advisable. So that's where actually extension to this gateway pattern, where like backend for front end concept is introduced, where we would be exposing the backend services as a as expected by a front end to them. Basically, our service contract will be built as per the need of a specific customer experience. So the customer experience, when we say we need not have a different interface altogether for a Android and iOS. If the user experience is same, then in that case we will still be able to render the same set of services. Now, by going by this approach, what happens is the bottleneck in during the maintenance time, like if anything goes wrong or if anything has to be upgraded or any change has to be deployed, so that time it won't be a bottleneck situation. So app journeys will still be working, and the web journeys can be, uh, I mean, the APIs concerned to that can be updated there. So this will be our one approach for exposing the services basically. Then comes the deployability. When we say deployability, once the services are designed, basically from the configuration or setting up the infra to scalability or monitoring it, or we maybe setting up a DevOps or pipeline setting up, or even the what I can say the process on which is followed. So this all basically consolidates, or this all actually is related to a deployability, or this says how efficient we are basically to achieve or like handle the microservice architecture. Now, this is something can be understood with different levels actually, as we have given here. So the containerization and container orchestration would be a first point where like we might have to focus. So service which is independently deployable will be wrapped as a containerized, or it can be containerized with all its dependencies, so that it can be scaled on its own. So that can be achieved using different tools like Docker actually. And container orchestration can be used like Kubernetes, using Kubernetes or Docker Swarm or anything like that. So we have a lot of tools mentioned here. So not everything need not, I mean, can be used with a single solution. We can pick and choose based on the need and what benefit it gives to us, and also the cost and other things definitely matters. Next comes the service mesh. So wherever we have to communicate within the service, or if there has to be a circuit breaker has to be set, or message transmission has to happen, that's where actually like we can use the service mesh concept. So Istio is one famous thing which can be used, and there are different other tools also in the similar way. Next is the API gateway, as we saw in the previous slide. So exposing it via the gateway would have benefit of its own. So whether it is throttling or authorization or message transformation is something we'll be able to achieve. Digit Market API Manager is something is a Tori Harris product where we'll be able to give the best out of this particular gateway, and is successfully implemented in a lot of client applications. Some of other gateways are APIG and AWS API, and we have some other tools as well here. Next is serverless architecture. Instead of keeping up the server every time if the usage is less or the usage is specific, so instead of that, bringing up a code as or based on an event, basically bringing up a server is something is advisable. So it might have some warm up issues, but still, like based on the need, I think this can be used. AWS Lambda is one. AWS Lambda, Google Cloud Functions are something which we can use in these cases actually. Next comes the log consolidation, tracing, and monitoring. This is a very important thing in a microservice, because as we are in a distributed environment, as I said, like handling issues or like handling a particular situation from an operations point of view, if you see, that will be much simpler if at all we are having the right set of tools. Log consolidation, for example, if you see, whenever we have a microservice architecture with each services is scaled on its own, if there are multiple replicas, identifying all those replicas to fetch the right logs from all of them, identifying the pattern out of that so that it can be fed into a monitoring tool, what we have said, or alerting tool, what we have said, is very important. That's where actually the log consolidation comes into picture. So like that, for monitoring also, we have different tools which can be used to set a better monitoring solutions. DevOps and continuous delivery is not only just setting up a pipeline, it will also be a change in the process where instead of, if at all we have to adopt to a governance standards in terms of code quality or in terms of basically a certain level of code security has to be maintained. Everything can be integrated in a pipeline, and for each service we would be setting up this so that the deployment time is reduced and we will be able to deploy things much quickly. Next comes the zero downtime. Definitely during a deployment, if there is any downtime which is observed, so that something can be achieved using, can be avoided. Zero downtime can be achieved basically using different deployment methodologies like blue-green deployment model or canary deployment model, where we ensure that we divert the traffic to a certain, older piece of code when we are upgrading to a newer piece of code, and then we divert it back, or we gradually increase traffic on the new piece of code, ensuring that service is always available with the right set of feature, or like with the basically older feature also still it is available. Next comes the infrastructure as a code. Infrastructure state file, basically state of that whatever is written. So these particular tools actually can read that, and based on the configuration what we feed, so they'll be able to make a change on the infrastructure level, so that for every deployment, if there is a need for making infrastructure change, that something can be automated using these kind of tools, so that we reduce the effort there. Similarly, when it comes to externalizing configuration, something which can be kept out of the service, which can be different for each environment, so it will be pulled out and can be kept as a different configuration altogether. So all these things basically helps us achieve better deployability or makes our life easy once things are developed. So every stage which comes after the service development till the deployment and then maintenance, basically, it makes it easy. So that's something we can achieve from a deployability. Next comes the communication pattern. So synchronized pattern where like we have interconnected services in a sequence basically called one after the other, and the client will be waiting to get a complete response, is something which is okay to use in some cases, but it definitely has certain other challenges as well. But something which actually helps for a better scalability, or basically for fault tolerance, or in case of a failure of one service, ensuring that still the data is not lost, or the basically we will be able to handle this particular situation in a better way, is something can be achieved using event-based communication, where we have a publish subscribe kind of model, which can be achieved using Saga pattern. So there are two flavors there. Choreography pattern, where we ensure that every service knows exactly which is the next service which need an event to be generated, which will be subscribed to that particular event, so that for every update on, say for example here in the order, the first example where like we have an order microservice, for every order creation, uh, when the database is updated with the order creation detail, there has to be an event created specific to the customer microservice, which goes and checks, do we have enough balance for that particular customer to create an order? If the check is green, it's successful, then in that case, it would give back an event which will help give a right information to the customer as well as update the order as completed. Similarly, if there is a failure in terms of identifying that okay there is no enough if there is no enough balance, in that case an event would be generated which will further help the order service to say that yes, the order is not completed because there is no enough balance, and give the information back to the customer. So this is a kind of pattern where like each service knows which is the next event has to be generated, and which is the next microservice which will be listening to this. So in this kind of pattern, we can use it if at all our solution is simpler, and we need not have a lot of services in this particular sequence, because in a solution like introducing a new microservice in between in this pattern becomes a challenge, because we need to keep a track of which service creates an event for what. That's when actually another flavor of that orchestration pattern comes into picture, where we would be having an orchestrator which has a track of the services which are participating in these events actually, and as well as like what is the sequence in which events has to be generated for them. It takes ownership of generating those events. At the same time, during the failure, there is a compensation journey executed, which knows in case of failure of a particular microservice, what exactly has to be done, say whether it is a data reversal or a retry. For example, in this, in case of order creation, if a payment has to be a payment microservice should do its job of making a payment. At the same time, inventory has to be updated and the email has to be sent. So in case of payment failure, order has to be reversed or it has to be mentioned as cancelled. So the orchestration knows in case of a payment failure, our compensation journey should have a reversal of payment as well as order. Whereas in case of inventory failure, it need not be the same case actually. So here what happens is this is something internal to the enterprise. The order need not be cancelled just because the inventory is not updated. That can be something handled with the retry, or even in a case of email, basically it can be handled with the retry. So that's how actually a logic or a sequence can be written in this orchestrator and it can handle. So basically, event-based communication pattern would help us in a better fault handling as well as in case of any scalability. Basically, for scalability, it helps a lot. So this is one thing. Next is availability over eventual consistency. So consistency, availability, and partition tolerance, it forms a CAP theorem. We need not go deep into that. But what is the concept or what is the main point in this is any given time, if at all there is an option for a customer to choose if service availability matters or exact or up-to-date data matters, then he or she would be actually interested to go for availability over consistency. And that's where actually the concept of availability with the eventual consistency is maintained. That means service is made available every time, data is made available every time, but as and when there is an update, it gets updated or synced up in all the databases, and that data consistency is maintained eventually. So there are certain patterns to achieve that. So the service data replication pattern is one thing where, like, if you have an external database with the right set of data and it has to be filled in the internal database so that a microservice can fetch from there and give a right information to the customer. That something can be used, achieved using tools like ETL in a scheduled manner or something like that. Then comes the CQRS pattern, where we basically split the read journeys and the write journeys, or what we call it as command journey, the weave journeys, or query journeys, basically. Each would be having a database base of its own. As and when there is an update happening on the right database, we ensure that this is synced up or like eventually passed on that information to another read database, and the read services are always available with the up-to-date snapshot or maybe a slightly previous snapshot of the data. So then comes the event sourcing pattern, where we, instead of creating a database entry for every update, we would create the events of every update, like that row 1 is created, row 2 is updated. So something like that. Those events, what is created, there will be a set of listeners to the services which will be subscribed to that, and those services would pick that event, and from their last update, they will further update their databases so that the data gets updated eventually. So if you see this diagram, we can see that we have used CQRS and the event sourcing pattern, where we are splitting the read journeys and the write journey separately. So each one is having a database of its own, and as we have an event sourcing pattern, we have an event store where, like, for every event or every update, basically, or a create, basically, an event gets created, and whatever event is published, that will be picked by a read service to update its database. At the same time, a service which is subscribed to this particular event, some other service which is interlinked or like has a dependency on this particular data, that also updates its database accordingly. So using this particular patterns, basically what we will be able to achieve is basically consistency of data by keeping a focus on availability of the services and the data. Next comes the single responsibility. That's a basic thing in a microservice, that we say it should be bound to a certain context and should be granular and should do a certain functionality. Now, how do we actually achieve that? Or the first challenge what we had, which we discussed in our previous slide, is that defining a bounded context is our first challenge. Now, how do we achieve that is something via different patterns what is provided. One of them is like domain-driven design pattern. There, what we do is like from a domain perspective or from a domain angle, from a top-down approach, if you see how a microservice can be viewed is something we'll be able to, in the same way, we'll drill down and arrive at a microservice. Now, this can be achieved with multiple stages. Unlike first is analyzing a domain, and then the defining the bounded context, and then coming to the microservice part actually. And when we say analyzing a domain here, when we say is it can be a banking domain, it can be a telecom domain, or any other domain basically. So we first come understand or come arrive at a subdomain level or even a modular level actually, like a order or payment or anything. And then further what we do is like we come up with a blueprint of those models or the domain models basically. um, Once we are having that, then we need to define a bounded context here. When we see a bounded context, we need to use basically a common language. Now, for example, if I'm going to bank to create a bank account, when I say please create a bank account, it has a certain bank account has or a account creation has a certain meaning for a bank manager. Same thing if I say to a architect who is working for a banking domain. So even he has a certain meaning of creation of a bank account. And similarly, same thing if I say it to a developer, account creation has a certain meaning in his perspective. So it might be an entry in a account table. So all these people, even though are in a different area altogether, so they will be actually interlinked by this common language of understanding what is an account. Now that is something we call it as ubiquitous language, where it's nothing but a common language which can be used across. So when we are arriving at a bounded context, we use this concept, and we then we see what exactly is our bounded context, or what is something within which like each entity or an element has certain meaning. For example, if you see this diagram, so we can see that there is a customer mentioned there. A customer who is making call to a customer service might be having certain set of data, and he might be a same person from who is making a payment. So within the payment module, he might be called as a payer. So there is a different meaning altogether, or with that context, when we see it has a different meaning. The same detail, if we see from a user management perspective, so we have a different meaning for that. So he might be called as a user. So within a context and across context, actually, they have certain meaning and the relationship, which can be achieved using a context map. This will be our second level actually. Then post that we go to an entity level, we define and see like what can be defined as an entity, which can be directly mapped to a table or a database basically. So and then we aggregate that, and then we define a service over that, which the purpose of that service will be basically to update that particular entity or to create that particular set of data. Now that's how we arrive at a complete solution using a domain-driven approach. Now these are some of the approaches what we can definitely like follow in our process of transforming it into a microservice. These are not the complete list. We will be I think in every stage we will get some more information actually, but these are some basic things which we can adopt. Now not every approach can be applied for every solution, but yeah, definitely some of them we'll be able to use in most of the solution. So one of such solution which we implemented for a telecom client, who is a UK-based telecom client basically, is this. So where we had gone for a domain-driven design approach, and the customer management journey was written as a microservice. It was basically exposed using, I mean, the integration segregation was done using the backend for front end concept. Again, in this, like the containerized using Docker, and the Kubernetes was used for orchestration. The complete solution was developed as a Spring Boot application. API gateway, APG was used as a gateway there. And for monitoring, if you see, like application monitoring was done with the EL stack, and then the platform monitoring was done using Prometheus and Grafana. So uh, not every pattern is used, but yes, definitely some of them are used, and we were able to arrive at this particular solution. So what I want to conclude with this is that if at all we are going for any solution, I mean, any microservice based solution always looks simpler and technology looks interesting. And the benefits, what we see from a microservice is always fascinating. So if at all we want to, with this actually, if we move to a microservice architecture, that's not sufficient without having a clear information of what are the pain points in a current architecture, what are the challenges which we might get if you're moving to a microservice architecture, we will not be able to take a right decision on what approaches we need to use and how do we, which tools basically are required. And if we don't have that particular analysis, we will not be able to arrive at a right solution. So what I would like to say is that let's stop, think, and revisit our transforming approach by understanding what are our challenges and the pain areas to arrive at a complete solution, so that our solution is not just tool centric, it's not using the technology just for the sake of using, but we definitely like come up with a customized solution which is basically a need of the day, and we will be able to achieve the best benefit out of the microservice architecture. So with this, actually, I would like to conclude my presentation.